Assalamu alaikum. Welcome to lecture number 3 of Software Requirements Engineering, CSC305. I am Dr. Naveed, and let's quickly recap what we covered in our previous lecture. We started off with our discussion on systems engineering, and we discussed the systems engineering process, where we said that when we talk about systems engineering, so what is a system? First of all, we try to define a system. So we said at times a computer software needs other hardware or other modules to be integrated with it, and then it becomes the whole system. So when we talk about in general requirements engineering and we are developing a system, then there is a difference between requirements engineering and software requirements engineering, because software requirements engineering will only concern the requirements of the software that is part of that big overall system. So we said that in a system engineering process, we would have requirements engineering, which would be followed by architectural design. Then we will partition requirements, and then we'll do software requirement engineering to understand what are the requirements, particularly for the software portion of the complete system. Then also we discussed some emergent properties, because we have different modules in a system, and when we try to integrate them, then some properties emerge, and those emergent properties might be related to reliability, performance, safety, and security. And as a requirement analyst or as a software engineer, we need to think about those emergent properties as well. Then towards the second topic that we covered in our previous lecture was a requirements document, and we discussed that what should be in a requirements document. We discussed some guidelines. For example, we said that the language used in a requirements document, it should be concise, it should be consistent, and it should be easy to understand for the people from different background. And another interesting thing that we talked about was users of the requirements document. And so who are generally the users of the requirements document? It would be the client, it would be project manager, it would be system developers, system testers, and maintenance guys. So, so a requirement analyst might write the requirements document, but there will be lots of users who would be reading that document. And so we said that a requirement document may be written once, but it would read many times. So we need to put, we need to be very careful when we are preparing that document, that we take care of all the users who will be using this particular document. And then we looked at one of the templates, which is IEEE template, and which is a standard, and it includes some of the sections which may not be present for different companies' requirement document template. And why is that so? Because that is a very generic template, and according to your company's context, and what is the context of any organization? Context includes the size of the organization, the type of the products the organization is into, type of the clients that the organization is targeting, and types of software that the organization is making. So depending on the context, you may need to change the template. And I think it is more advisable that you change your template, because it will give you more clearer understanding of the requirements. So then we discussed a template for a particular organization as well in our previous lecture. And towards the end of the lecture, we started looking at an example. And that example was of a student project that we did for Comsets University, which was bus locator. And the idea was that students should be able to know where their bus the bus on their route, where it is at the current moment, so that they can time their distance from their home to the bus stop. And similarly, the transport office, they can also track where all the buses are on their different routes, and they can also maintain the route history. And the idea was that I share with you something so that you know how the requirements are expressed and what are the different sections and what we put in different sections of a requirement document. And we were not able to finish that example, so in today's lecture, let's quickly go through that remaining part of that example, and then we'll move towards today's topics. So let's look at the example that we were into. So we started looking at we were at the section 3, which was specific requirements, and we were looking at functional requirements. And from the functional requirements, we looked at the first one, which was get bus location. And just to quickly summarize, we mentioned in our lecture that a requirement can only be expressed as natural as a paragraph or a simple English or simple line of text. And that would be sufficient. But there are different ways of expressing requirements, and and the template that is used in this particular document is slightly different. It's a tabular form, and in a table we have said that there are different things for each requirement that we are putting in. And what are those different things? We are assigning a unique identifier to each requirement, which is always a good idea, because we want to track our requirement. We want to track all the changes in the requirement. We want to track whether the requirement is being tested, implemented, or where it is in the design stage. So it's always a good idea to assign unique identifiers to each requirement. Then there is title of each requirement. For example, get bus location is the title of this particular, the first requirement, then the text of the requirement. Okay, and as I said, that can be the only thing that we have in a requirement document for each requirement. But in this tabular form, we are adding some more information because we want to gain better understanding of each requirement. So what was the requirement text? That the drivers of different routes shall be provided phones through which GPS locations shall be transmitted via GPRS network. Current GPS coordinates shall be updated on the server every 30 seconds. So this is a very interesting statement, and it is also quantitative statement, as we mentioned as one of the guidelines of expressing requirement, that they should be quantitative statements. Why I say it's quantitative? Because another statement could have been that current GPS coordinates shall be updated on the server. Now that statement was not actually quantified, that how frequently should the GPS value be updated. So we have explicitly said that after every 30 seconds the new GPS location would be sent to the server. And then there is rationale of the requirement, another section in the table, which says that this requirement is central to the project because the client-side application depends on the current location of a bus, so server shall get location of each bus. So rationale gives you more understanding that why we thought that this requirement should be part of our software. So rationale is something which is necessary to give logic behind, why we are doing, why we are adding certain service in our software. And then if there are any restrictions and risks involved with this particular requirement, we need to express that. For example, it's written here that there are none, but there can be many. For example, the GPRS network is not working, or you're not able to send the current location of the bus to the server. What would you do then? So I mean, there are some risks involved which are not mentioned here, but you can think thoroughly, and you can put those risks here in this particular section of risks. Dependencies, obviously it's written that there is no dependency here. In terms of dependencies, why this section is here and what do we mean by it? In particular, when we were preparing this document, so dependencies meant that whether this requirement is dependent on any other requirement. So obviously this is the first functional requirement we are talking about, so we are saying that it's not dependent on any other requirement. What's the priority of this requirement? The priority is high. Priority expressed on 3 different scales: high, medium, and low, with high meaning that this functionality is really, really important for the software. And why this is important, we have already expressed that in the rationale, that if we do not do it, then our client-side application, which is the student, which is for students who have the smartphones and they want to know where the bus is on their route, they will not be able to see the current location of the bus if it's not updated. So that's why this requirement is really central to the software. So the next requirement was main location of all the buses. Because as we said in the problem statement, that one of the goal of this software of this software is that the transport office of the university, they want to track all the buses. Why do we need this requirement? What does this requirement say? It says that tracking buses involves maintaining location of all the buses at the server side. So get bus location was for one particular bus, but we are saying we have to maintain this information for all the buses, but not just one bus on one route. And what is the rationale? This requirement is central to the project because the client-side application shall depend. So it's kind of similar, the first part, but the second part is server is responsible for maintaining GPS data for all buses. So server would have different tables assigned to different routes, and they would be keeping track of all the buses. So GPS location would be updated on those tables. So what are the restrictions and risks? Lag in the network may cause unexpected delay. So for example, as I said earlier, that if the GPRS network is not available because it's not one of the most reliable networks on which the traffic is sent, you might not be able to get the updated GPS coordinates, and it can happen that the update that you sent supposedly from the driver side application after 30 seconds didn't get to the server. So that was another requirement. So this gives you in terms of dependency, we are saying that this is dependent on the first requirement, because what was the first requirement? The first requirement was get the location of the bus, and so this we are saying that this is dependent on the first one, and again the priority of this is very high. And then we have expressed some more text. We have said the user at the server side shall be able to view location of all the buses in real time. Students once registered shall only be able to view the location of the bus on their route. So a student cannot see the location of all the buses on different routes. He or she would be only able to see the location of his or her bus. Right. So these are some of the server side. So this is a client side requirement. So view bus location. So we'll quickly look at this one, and then we'll move to the non-functional requirements. So what is the title of this requirement? It says view bus location, because that is the service supposed to do that. A student should be able to view the bus location. And what does the requirement text says? It says updating destination of buses on the map, or updating location of the buses on the map. So what is the rationale behind this? Client side shall provide view of a specific bus on the map. Client side shall query server every 10 seconds to get new location of the bus. Now one question can be that why we are querying the bus every 10 seconds, but that's not part of the discussion right now. But the reason was that because at times you are using your smartphones, you are sitting at home, and at times you're out of reach of your Wi-Fi. So because for a student it's really important to know if bus is near their home and they need to rush to the bus stop or not. So that's why it said that we need to do it more frequently than the driver side application. And this also has dependency on some of the previous requirements. For example, it is dependent on the functional requirement 2, which was location of all the buses, and the priority of this requirement is also high. So these are some of the functional requirements, and you guys can see that, as I said, that there are different ways of expressing requirements. And in this case, we chose a tabular form where we wanted to express certain things. We wanted to know we wanted to assign an identifier to each requirement. We wanted to write the text of the requirement, which was we wanted to make it quantitative, and wherever we can we had. And then we wanted to write rationale of each requirement, along with the restrictions and any risks that this requirement may have, and then the dependencies of a requirement, and then the priority of each requirement. So these are all the functional requirements: user configuration, setting alarm, status update, and route history. So let's look at non-functional requirements. And the non-functional requirements of bus locator project are expressed in the form of usability requirements, reliability requirements, and performance and supportability requirements. And let's look at one of these just to get an idea how do we express non-functional requirements of any software. So in terms of performance, we had 3 particular concerns: response time and throughput. We wanted to ensure that the information transfer between the client and server side shall be minimized in order to increase the response time. So that was one of the concerns. The second concern in terms of performance was capacity. How many number of students can access the server at one time? So we set an upper limit of 200 students accessing the server at any given time. And then resource utilization. So we wanted to minimize that, because on the client side we are not storing any information. The only information that is saved on the client side is when a user configures his or her home address. For example, a student wants to tell the application that where my home is, so that is the only information that is maintained. On the server side, though, we are trying to maintain the route history for each bus. So that would take some space, and we need to mention that how much space it would take and after how many days. So basically that's how so let's see how we express these requirements. So the first one is the title of the first requirement is minimum traffic on the GPRS network, and the text says the data transfer between client and server shall be minimized. And the rationale is data transfer between client and server shall be minimized as data will be sent using GPRS network. And as we said, that GPRS network is not the best mode of communication, because you guys should remember that a little while back when this project was done, then the 3G was not active in Pakistan, and we were only on sending data through mobile phones over GPRS networks. So that was the limitations then. So some portion of this requirement is already taken care of in the functional requirements, where we said that we have mentioned the frequency of the data which would be sent through GPRS network. For example, one of the requirements said that after every 30 seconds from the driver side, the GPS coordinates would be sent to the server. So we're not saying that try to do it as frequently as you can. For example, try to do it on, after every 5 seconds. So that is already minimized. Similarly, from the student side, when we are trying to access the server, we are also trying to minimize that. We are saying after every 10 seconds, try to go to the server and get the new GPS coordinates. So that is slightly taken care of. Then the second requirement was usage capacity. So we are mentioning that maximum of how many users can access the server at one time. So we've also assigned a limit to it. We said it should be able to support 200 users trying to access the server at any given time. So this is how non-functional requirements are mentioned. And you can see that we have also assigned the priority to even non-functional requirements. So for example, the first requirement, which was minimizing traffic on the GPRS network, the priority given to this requirement is high, because this is really, really important that we achieve that. Why this is important? Because if we don't do that, then our whole application would not work properly. And the second one, usage capacity, although this is also important, but its priority is low in comparison to the other one. So this is how we express the non-functional requirements of a system. And then we have supportability. Then comes the next section. After we express the non-functional requirements, then we can put some design constraints. So for example, we are saying that agent side will be developed as a native Android application, and it will support devices running Android 2.0 or higher. And we are also trying to mention what tools or technologies we are going to use. So we are saying we'll be using Eclipse IDE for building or compiling our Android application. We are going to we obviously we're going to need Android SDK. We'll be using Java. On the server side, we will be using HTML, PHP, and MySQL. So we have also mentioned what tools and technology we will be using. So in terms of online user documentation and help system requirements, there is none. There are no purchased components. And then comes the section on interfaces. So when we are expressing our requirements, then at times it is very important that you try to visualize how your system would look like. And when we write interfaces, then this is the section where you can actually express that. So in the user interface section, we have put a couple of screenshots just to show that how our client-side application and how the server-side application would look like. So this is a sample of that how a student-side application would look on a student phone, which will obviously show Google Maps, and on the maps it will show the location of each bus with marker pointing the current location of the bus. And it's a dummy interface which clearly says that it's not the actual interface, it's just a mock-up. And then this is the server side, which says that this is a bus locator server, and you would be able to see different routes. And the route 5 is the one which is basically highlighted, and you can see the location of the bus. So you can also have multiple, because this was a pretty simple application with couple of screens on the student side or the client side application, and few screens or a few web pages on the server side, with the main one was knowing the location of each bus. Now, so they are shown here, but again these are all mock-ups, because at this stage you can only produce mock-ups. But it is always a good idea, because when you will show these kind of mock-ups to the client, then they can have their input on it. So if they want any improvements, or if they don't like it, they can tell you right then and there, so that it will avoid lots of unnecessary rework. So this is really important that you think about what will be the user interface of the application, and if you can produce something, then share it with the client. So what are the hardware interfaces? Obviously on the client side we have Android devices. At the data side, on the server side, basically we'll be using some servers to store the location of the buses and maintaining the route history. And what are the software interfaces? So we're saying that they can be divided into two categories. Client side, we will have Android SDK. We will be using a couple of APIs, for example, the Google Maps API. On the server side, our server side, the software interface would be presentation layer, which would be HTML, logic layer, PHP, and database MySQL. And what are the communication interfaces? So in communication interfaces, we have already told that our application is divided into three main sections. Couple of client application, which is driver side application, and a student side application, and then we have a server. So we are showing that we have a client side, we have a server, and then we have a driver side application. And there are no licensing requirements, because obviously all the tools that we are using or all the technologies that we are using, they are open source. And if there are any applicable standards, we do not know at the point of writing this requirements document. You can always say they will be specified later. So this is just a sample requirements document, and as I said in the beginning when we started discussing this particular example, that this is not perfect, but this is just an example or give you guys a flavor that when you are expressing requirements and how do you write different things in it, and again remember what we discussed as what are the guidelines of writing requirement. It should be concise, complete and consistent, and they should be simple and easier to understand for all the users, and moreover they should be according to your template. So you can adapt a template, but you should always customize it according to your particular needs. So that's it from this example. In the course of the lecture we will be looking at more examples, and we will try to come up with different sorts of examples from different industries, so that from different sort of software companies, so that you guys can get an idea how different how the requirement document template changes when a context changes. So let's come to our today's topics and see what we will have, what we'll be covering today. So we have already done the bus located example. We have done that, and today our main goal is to know what are the different tasks or what are the different sub-processes involved in the requirement engineering process, and we will be discussing them briefly. Obviously, as part of this course, we are going to talk about them in detail. For example, in today's lecture, we'll just introduce these different sub-processes. For example, we'll know what inception is, what elicitation is, and if time permits, we are going to talk about elaboration, negotiation, specification, validation, and requirement management. But this is just an introductory lecture of these sub-processes. Following these lectures, we are going to talk about each of these sub-processes in detail, and we are going to discuss what are the main tools and techniques out there which are used for inception, for example, what are used for elicitation, how we analyze or elaborate requirements. So we are going to do that as well in the later lectures of this course. And before we get to that, before we get to the requirement engineering process, let's quickly recap that what are the problems with requirement practices. We discussed some of the problems with requirements. We also need to discuss what are the problems with requirement practices and why should we follow these tasks, or why should we go through these tasks, and this is just to appreciate the importance of these tasks. So let's quickly see what are the problems with our requirement practices. So the first one is that we have trouble understanding the requirements that we do acquire from the customer. So that is a very clear problem that we have, that customer expresses something and we do not know what he is trying to say. We basically just for the sake of it, when somebody tells us something, we say okay, we understand it, we document it, and when we come back we actually cannot remember, or we actually cannot relate it to the rest of the requirements. What was he saying there? So so that is one of the problems. We often record requirements in a disorganized manner. So how requirements can be organized in disorganized manner? For example, you are making a university management solution, or a learning management system, and you have a students module, you have a faculty module, you have a course module, and you also have administration on it. So when we are expressing requirements, ideally all the requirements related to the students module, they should be documented with each other. The benefit would be that if there are any conflicts or if there are any inconsistencies in those requirements, you would be able to identify them. But if the structure of your requirement document is such that you are expressing some student requirement, then you move to administration, then you move to faculty, and then you jump again back to students, then this will not be very readable. So you should, that is one of the problems, that we record requirements in a disorganized manner. And we spend far too little time verifying what we do record. So verification is really important, and this is something we discussed in our previous lecture as well, that we need to give some time to verify requirements. We need to give ourselves some time to redo requirements. If, for example, after verification, we figure out that there are a few problems, and what we have documented, customer doesn't like it, and he says we need to change some of the requirements, then we need to give ourselves some time so that we can verify and we can re-record or rewrite those requirements before we go to design and implementation and later stages of software development lifecycle. We allow change to control us rather than establishing mechanisms to control change. So this is also really important, that you should be the one who is leading this whole process. And for example, you need to develop mechanisms where you have a process in place to accept a change or to reject a change. And you should not be dealing with the changes in a way that whenever a change request comes in, you just incorporate that in your document, because then it will be a mess and you will never be able to finish your project on time. So you need a mechanism where you assess every change, and you need to negotiate with the client in a fashion that you try to accept most of those changes which are beneficial to your design, which are beneficial to your in-time completion of the project, and which are beneficial to your understanding of the software. And you should try to minimize the impact of change on the overall software development. So we need a mechanism to incorporate changes whenever they come. Most importantly, we fail to establish a solid foundation for the system or software that the user wants built. So because of all the above problems, lack of understanding, disorganized requirements, we don't verify requirements, we don't have a mechanism for change control, we fail to have a solid foundation on which our system should be built. So these are few of the problems, and there are few more. So those were the requirement practices problem from requirement analyst point of view. Now from developers point of view, what do developers do? Because at times developers are so enthusiastic about writing code that they do not give themselves time to actually understand the requirements, and whatever they comprehend of it in the first go, they just say, okay, let's start coding it. So before you actually jump into development, you should have a clear and very clear understanding of the requirements, and this is very important. So that's one of the flaws in our practices as developers. And what they believe is that things will become clear as we build the software. So this is again a very wrong understanding. And project stakeholders will be able to better understand when they need only after examining early iterations of software. So another belief that the software developers have, that we will go through first few iterations and we will share them with the client, and they will identify, okay, what are the problems with it. And they don't actually worry about that the first few iterations are actually the foundations of the software, and they are core of the software. And if the core of the software is built incorrectly, then how can rest of the software which is built over the core would be correct? So this is again a very wrong perception about jumping into development rather than understanding your system properly. And another belief is that things change so rapidly that the requirement engineering is a waste of time. So some people do believe that why waste so much time on elicitation, elaboration, why spend too much time on negotiation and validation of requirements, because they are going to change anyways. So let's quickly jump into coding. So that's again a very wrong understanding that people have, and they believe the bottom line is producing a working program, that all else is secondary. So according to them, that in the end we have to give some functionality to the client. So why waste time on analysis? Whatever we understand, let's give to the client. And if it works, then he will be happy. If not, then requirements are going to change. So again, these are wrong perceptions, because there are few things that we need to understand as software engineers, software developers, and part of software community, that whenever we are expressing requirements, and when we are trying to understand requirements, and when we are trying to implement our software from those list of requirements, then the initial increments, they are actually the core of the software. And if your architecture is built on wrong assumptions, then the changes that would come in afterwards, they would be very, very costly, because you might need to change your architecture. Or if you don't change your architecture, then you would have to maybe write very, very long pieces of code in order to get through the problem. So again, we need to thoroughly understand requirements and then start coding. So all of these arguments contain some truth. We need to believe that people say that we need to develop some functionality, and we need to show something to the client as quickly as possible. So for smaller projects, which are whose duration might be less than a month, they might be true. But when the size of the software grows, for example, you have a project which you have to complete, the completion time of the project is more than a year, 2 years, 1.5 years, or even more than a month, then the complexity of the project increases, and the implication of a wrong architecture design would be huge in comparison to a project which is smaller. So when the size of the problem increases, then the wrongness of these practices, it comes to light more. So we need to actually adopt right practices in order to build software in a correct fashion and build a correct software which is acceptable for the client as well. So what is the solution to all these problems? Solution is, obviously we are saying that software requirements engineering is a solution, because if we follow a proper methodology, or if we follow a proper engineered way of understanding requirements, then we can deal with those problems. And how do this process begins? It begins during the communication activities and continues into the modeling activity. Builds a bridge from system requirements into software design and construction. We are going to see that how requirement engineering helps translate requirements into design, and that is where the elaboration sub-process of the requirement engineering process plays its part. Requirement engineer, this whole requirement engineering process, it allows an engineer to examine the context of the software work to be performed, the specific needs that design and construction must address, the priorities that guide the order in which work is to be completed, the information, function and behavior that will have a profound impact on the resultant design. So this whole requirement engineering process, it basically gives you more understanding about those requirements, and that is the crux of it. If we have better understanding of the requirements, then it will ensure that whatever we produce is the right thing, and is the thing or is the software which the client wants. So what are the different tasks in requirement engineering? And as I said in the outline portion of this lecture, that there are 7 distinct tasks in a requirement engineering process. The first one is inception, then elicitation, elaboration, negotiation, specification, validation and requirement management. We are going to briefly talk about each one of them in coming slides. But before we get to that, it's important to understand that these are not all sequential tasks. So we're not saying that we can only jump from inception to elicitation once this is complete. No. So we are saying that inception, it can go in parallel with elicitation. So we will be doing these things in parallel. At the time we are eliciting requirements, we will also be doing elaboration, and we can also do negotiation with elaboration, and then we can do we can also specify requirements once we are eliciting them, elaborating them. We can also specify some of the requirements. So these are not all sequential tasks. We can do them in parallel. So the goal is that we try to define whatever customer wants in a clearer fashion, and we want a solid foundation for design and construction of the software. So these are the tasks, and let's look at what inception does. So what is the inception task? During inception, the requirement engineer asks a set of questions to establish. So inception is just a communication activity, but it's a targeted communication activity. What we try to do is we try to gain some insight into how can we collect requirements from this client, or how can we collect requirements, how can we reach this client. So that is the goal. So we do this inception to gain to establish these things: a basic understanding of the problem, the people who want a solution. So who are the people who want this particular solution in the overall organization? Who are the people who are for this particular software? And the nature of the solution that is desired, and the effectiveness of preliminary communication and collaboration between the customer and developer. So we also want to establish that. And what are the goals from these questions? We try to identify the stakeholders. Now this is very important step. I don't think we actually discussed very formally that who are stakeholders. In general, we defined in one of the previous lectures that who are stakeholders of a project. So anything who has any interest in the software that you are building is a stakeholder. So it's the client or the project sponsor, the project manager, higher executives at the software company side, then the developers, testers, engineers, even the competitors. They are all stakeholders of the project. And one of the goals of the inception process is that we want to identify the stakeholders. We want to recognize the multiple viewpoints. Now this is also, what is a viewpoint? For example, let's consider the example of a university management system that I mentioned earlier. And there can be multiple stakeholders in a university or in a learning management system for a university. For example, one of the users can be students. Okay, Now students would have their view of the system, and according to their view, registration process should be done in a certain fashion. So for example, student would have their view about this whole registration process. Now another viewpoint of the system might come from another stakeholder, which is the administration, and they would have their own view about this registration process. And by registration process, I mean the course registration process, because both of these users, they are part of this process, registration process. Students want to register courses, administration wants to ensure that only the only the eligible students register a particular course. Another goal is to identify, because we identify different stakeholders, and through that process, through identifying different stakeholders, we try to understand what are the different viewpoints of those stakeholders. And then we work towards collaboration, because when we have different viewpoints of a solution, of a software, then there would be conflicts, and we try to move towards collaboration. We break the ice and initiate the communication, because there might be few things where those different stakeholders, they have conflicts. So we need to figure out a mechanism that how do we resolve those conflicts, because in order to build a software, we don't want conflicts in the requirements. For example, student might say that they want to register courses before they have paid all the fees. Now, one of the things that one of the practices that we have in our university is that students can only register a course once they have paid their dues. So there can be conflicts. That student might say that, okay, no, allow us registration, and then we'll pay the fee. Give us some more time. Whereas administration, they're very strict on that. So there might be a conflict here. So we need to figure out that whose view we have to accept. So that is where this Inception task is very helpful, that we get to know what are the different viewpoints. Okay, so as I said, that in Inception we try to ask different questions, and the idea of asking different questions is that we want to get an insight into the client's head. We want to know who are the right people, we want to identify the key stakeholders, and we want to understand those different viewpoints. So this is the first set of questions. These questions focus on the customer, other stakeholders, the overall goal and benefits. So we want to establish that what is the overall goal of the client from this particular software? What benefits do they expect from this software? So the first question is, who is behind the request for this work? Now this is a very important question. We will go to the client side, and whoever is the liaison at the client side will try to ask him that who is the requester of this work. And if he says that CEO is the requester of this work, then this is something which is very positive, because we know that the top management or the top executives, they actually want this thing to work. So, and that is one of the key aspects of any project failure or success, that if top executive or the top management support is there, then usually the project, that's a very good sign. So we want to know who has requested the work, who will use the solution. So in general, we want to know that you asked us to make a software, who will use this particular system, what will be the economic benefit of a successful solution, is there another source for the solution that you need. So these are the first set of questions. Then now let's go back to our bus locator example. Now let's say we wanted to figure out, we went to a university and we wanted to know who is behind request for this work. So you know, one of the possible requester for this work could have been the you know, in a university there is a very active department which is the student affairs department. So student affairs department, let's say we figured out that student affairs wants to give added feature to their students, that the students who are traveling on buses, they can also know where their bus is. So maybe we get to know, okay, student affairs want this. Then we ask them that who is the users of this system, who will use this. So they said, okay, students are going to use it and the transport office is going to use it. So at this point we clearly know that, okay, we have some users at the client side, but none of the top management is actually in there right now. So we want to know, okay, so what is the economic benefit for this to a university, or what is the benefit of this to a university? This is a very important and very important question to answer. It is very important because if we have any hurdles in a project, and if we have established that these are the benefits that this particular software will give to the client, then we can, if we are able to express that through our requirements document to the client, then it shows the importance of the software to the client. So although in this particular example of bus locator, we can see that, you know, in the top management support, we cannot see the top management support right now. But if we can somehow express the economic benefit of this software, then we can convince people that, okay, this is something which is important and they need to prioritize it. So this question is really important. This is important to make a business case for a particular software, that if we do that, then these are the benefits that we are going to get. And so these are the first set of questions. And the goal is we want to focus on the customer, we want to know who are the stakeholders, and we want to identify the overall goals and benefits. Then the next set of questions, they basically enable the requirement engineer to gain a better understanding of the problem and allow the customer to voice his or her perception about the solution. Now again, we are not asking very specific requirement questions. We are not asking from students that what do they want in a registration process, but we are just asking students about the software, that what do they think of this particular solution. So the first question is, how would you characterize good output that would be generated by a successful solution? So that is the first question that we are trying to ask our students, that let's say the registration process is automated. So how do you see what according to you is a good registration process, or what according to you is a smoother registration process? We are trying to know that. And similarly, we ask the same question from the administration, and they would have their say on it. And what problems will this solution address? Now, so we'll try to identify that what are the current problems that students face with the registration process. And we will gain our understanding about the current process, and then we'll try to propose a new process. And the next question can be, can you show me or describe the business environment in which the solution will be used? So that is a possible next question. And so we are asking the client, we want to observe how this process is currently taking place at your organization. So maybe one of the client will take us, or one of the person from the client side, they would take us to the administration office where students come in and they manually do the registration, and we try to figure out on our own that what are the problems with the current process of registration. So when we give them a solution, so our solution should be able to take care of those problems, because one of the problems that we saw was that whenever a student comes in for registration, then manually the administration had to look for whether the student is eligible for to register a particular course. For example, student has the right amount of GPA to go for this course, or student is in the right semester to take a particular course. So if these things are automated, then these things would be done automatically. For example, whenever a student goes to their registration or click the registration button, then only the courses would appear which the student can register. So this is a so that's one of the suggestions that we can give, that this is how we can improve the overall registration process. The next question can be, will special performance issues or constraints affect the way the solution is approached? So we can ask them that if there are any constraints on this process, or if there are any performance issues which may affect the way the solution is approached or not. So again, we are not asking very particular questions. We are not eliciting requirements at this stage, because that is the next process. That is the next task of the requirement engineering process. At this stage, we are just trying to feel what the customer wants and how do they do things at the moment. We are just trying to gain understanding of their current practices. So the final set of questions, they focus on the effectiveness of the communication activity itself, because all we are doing in Inception is communicating with the client. And we want to gauge that whether our communication is helpful or not. So what are the questions that we can ask? And these questions we can ask to ourselves, and we can ask to the client that, are you the right person to answer these questions? So we should try to establish that whoever we are talking to at the client side, is he the right person? And are your answers official? We need to establish that whoever we are talking to, whether whatever he says is official or not, because we need to talk to somebody who has got authority. We need to talk to the right stakeholders, because everybody at the client side would have an opinion, but we cannot possibly accept all those opinions. We need to pick those stakeholders who are key stakeholders, who whatever they say, it needs to be implemented, or their opinion matters. So we need to identify those people. Are my questions relevant to the problems that you have? So we need to figure out that whatever we are asking from this particular client,
whether they make sense or not. Because if we are asking the wrong questions, then it's guaranteed that we are not going to identify the right stakeholders. We are not going to gain any understanding of their current processes. So we need to ask the right questions. Or am I asking too many questions? Can anyone else provide additional information? So we need to identify even more people, because there are some people in the organization who know the overall processes. So maybe we are missing on those guys. So we talk to the client and say, okay, is there anybody else who knows about the overall process, who knows about the conflicts, or who knows about the problems in the current processes? Can we talk to those guys as well? So we are asking client these kind of questions. And should I be asking you anything else? So we need to figure out that is there anything missing at this point? And the goal, you can see from these set of questions, is that we want to establish the effectiveness of our communication. Because although at this stage we are not asking requirements, but we want to know that when we start asking requirements, we talk to the right people and we talk in a right fashion. So these are the set of questions that we are going to ask at the inception stage. So we've done the inception task of the requirement engineering process, and what we have seen in inception is that what is inception about? So inception is about, it's just some set of questions. So we ask some set of questions, and what do we want to know from these set of questions? So first one is that we want to understand the client. We want to understand the customer. And when we say we want to understand the customer, what do we mean by that? We want to know that what he wants, and we want to establish who requested this particular software. Why this is important? These two things are important because we want to know that who is the main person who wants this software badly. And as I said, if we get to know that the top management wants a particular service, then that is a very good sign, as I said, because top management support is one of the key success criteria for any software project. So we want to understand our client. We want to establish the benefits that the client perceives from this project. Then the next is we want to identify multiple viewpoints. And multiple viewpoints, why they are important? Multiple viewpoints are important because we want to know how different users within the system or how different users at the client side view the solution. We want to gain that understanding. So this is also again something very important. And then we want to establish through the inception process the effectiveness of our communication. And why we want to achieve that at the inception stage? Because the next task is very critical, because in the elicitation stage we are only going to target those stakeholders whose opinion matters, who are the right people to talk to, and when we get to talk to those people, we want to ask the right questions. So that is why it is very important to establish the effectiveness of your communication activity. So next up is the elicitation. So we are here. So next up is the elicitation. So let's go ahead and briefly see what is meant by elicitation, and very briefly look at a couple of techniques of eliciting requirements. There's something I want you guys to do whenever we are going through these different processes of requirement engineering process. I call them processes at times, I call them tasks. So why do I call them? Because a process is just a set of activities. Okay, so we can say that requirement engineering is a set of these activities, but I believe that even in inception there are small activities going on, and even in elicitation there are small activities going on. So I call them sub processes. So you can think of them as all of them as tasks, and you can also think of them as sub processes. So I will use this terminology throughout the course, because I always believe that elicitation is not just a task, it's a set of tasks. And when it's a set of tasks, so you can call it a process, you can call it a sub-process. So let's move ahead and see what elicitation is about. So eliciting requirement is difficult. First of all, you need to, I always try to tell people that it is difficult because When you appreciate that this is difficult, a process is difficult, only then you can pay more attention to it, and then only then you can, if you know the problem, only then you can try to address those problems. So now why it is difficult? The first problem is the problem of scope. In identifying the boundaries of the system or specifying too much technical detail rather than overall system objective, because at times what we do when we are eliciting requirement is that rather than knowing the overall system, we try to go in in-depth analysis, and that is not the goal of elicitation. That is left for the analysis part of the requirement engineering process or the elaboration part. We need to know what the overall system is about. Second is the problem of understanding that what is wanted, what the problem domain is, and what the computing environment can handle. Information that is believed to be obvious is often omitted. So when we are eliciting requirements, we should always try to know even the most obvious things, because we might think that something is happening in a certain fashion, but we need to clarify that when we are eliciting requirements. And problems of volatility. So that is a very general problem, because requirements do change over time. So whatever we elicit, it can change. For example, a client tells us something and later on he says, okay, no, we want this thing in a different fashion. So these are in general problems with the elicitation. And as I said, that we are going to discuss a couple of techniques. We'll see that how elicitation can be conducted. So in elicitation, we try to know the scope of the system. We try to generally identify what are the boundaries of this software that we are going to develop for the client, and what do they want within those boundaries. So there are a couple of techniques that we will be discussing very briefly right now. The first one is collaborative requirement gathering, and the other one is quality function deployment. So what is collaborative requirement gathering? Again, the goal is we want to talk to lots of stakeholders and want to identify what do they want in the system. So as the name suggests, collaborative requirement gathering would mean that we are trying to gather requirements in a collective fashion. So we are collecting people in some space, and we want to know what they want. So how it is done, this whole process of collaborative requirement gathering, how this technique is implemented, that meetings are conducted and attended by both software engineers, customers, and other interested stakeholders. So you would have very formal meetings where you would invite some clients, you would have your team members, and you will have all the other interested stakeholders sitting in one room, and you would have some rules for the preparation of the meeting, and participation are established. It is always an agenda-based meeting. So for example, you can have multiple collaborative requirement gathering meetings, and in the first meeting you might say that the goal is you want to discuss the student module of the LMS system, and then the next one say, okay, we want to address the course module of the LMS system. So the idea of setting an agenda is because it gives clarity to all the participants, it gives clarity to the customer to invite right kind of people to those meetings, and it gives them proper time to actually be prepared for that meeting. And in those meetings, there's normally a facilitator who controls the meeting. There is a definition mechanism because everybody is expressing their requirements. So you need to write those requirements somewhere. So for example, there can be different ways of doing it. You can, if the meeting is conducted in a big conference room with lots of people sitting there, you can have one mechanism, possible mechanism can be that you have a whiteboard where you're writing all those requirements. Another mechanism is that you use post-its. So you write requirements and you post them on the wall. And there can be virtual forums. You can have a virtual collaborative requirement gathering as well. You can have a portal where different users are sitting together. You can have a chat room where people are expressing their requirements. So these are there is always a definition mechanism when you are conducting this activity of collaborating requirement gathering. And the goal is to identify the problem, propose elements of the solution, negotiate different approaches, and specify a preliminary set of solution requirements. So again, this is very important to establish here is that that our goal is to understand the problem, and we want to identify some elements of the solution. But one of the advantages of eliciting requirements in a collaborative fashion is that we are trying to resolve conflicts at the same time, because when lots of people are sitting together And as we said, that registration is a dodgy area where students might have their view and administration might have their view. So we have some students sitting in that meeting and they say that this is how we believe the registration process should be, and the administration might have their own opinion. So when we are conducting this meeting and all of the stakeholders are sitting face to face, then this gives us a chance to resolve those conflicts as well. So this is one of the advantages of using this technique of collaborative requirement gathering over, for example, another technique which can be used for elicitation are interviews or questionnaires. So this is the advantage of maybe using collaborative requirement gathering. Obviously, we will go into more depth of collaborating requirement gathering when we discuss elicitation techniques in detail in later lectures of this course. Another technique that can be used for eliciting requirements is quality function deployment. So it's a technique that translates the need of the customers into technical requirements for software. It emphasizes an understanding of what is valuable to the customer and then deploy these values throughout the engineering process through functions, information, and tasks. It identifies three types of requirements: normal requirements, expected requirements, and exciting requirements. So basically, you can say that when we are using this QFD process, quality function deployment, to express the requirements, we are also ranking requirements. So what do we mean by normal requirements? These requirements are the objectives and goals stated for a product or system during meetings with the customer. Expected requirements, these requirements are implicit to the product or system and may be so fundamental that the customer does not explicitly state them. And exciting requirements, these requirements are for features that go beyond the customer expectations and prove to be very satisfying when present. So, quality function deployment is another method for eliciting requirements. So the basic idea of QFD is to construct relationship matrices between customer needs, technical requirements, priorities, and competitor assessment. So we try to make a matrix type structure where we have different things. We have customer needs, we have the technical things that the customer wants in the product, we have priorities of those technical things, and we also try to evaluate what do the competitors have and how we can overcome or how we can overachieve the competitors' solutions. And to achieve this, we need to do these following things. We identify the stakeholders' attributes or requirements. We identify technical features of the requirements. We relate the requirements to the technical features. So what do we do is that, so on one side we will have the requirements, okay, and on the other side we have some technical features. So what we do is that, let's say we have R1, R2, R3, R4, and here we have some technical features, T1, T2, T3. We try to relate them. The T1 is related to R1, R3, T2 is related to these. So we try to relate them. Then what we do is we conduct an evaluation of competing products. So we try to evaluate the competing products on these requirements and on those technical features. So we say that T1, which competitor is at what level. So we define a scale that from 1 to 10, which competitor is the best. So we can try to build our product which is technically better than that particular competitor. So on here we try to evaluate competitor on technical features, and here we try to evaluate client on those requirements. And then we try to prioritize these technical features. What would be the benefit of that is that we are trying to actually give importance to those. So as we said in our previous slide, that we try to identify the normal requirements, expected requirements, and exciting requirements. So this is something, another added advantage of QFD processes. So that is it, what we are going to cover in today's lecture. And before we finish, let's quickly recap what we have done in today's lecture. So let's quickly recap what we have done. We completed our example on bus locator. We saw how the non-functional and functional requirements are expressed. Then we discussed what are the problems with current requirement practices, and we discussed the problems from a requirement analyst point of view and how developers conceive the requirement engineering process. We discussed some of those problems with current practices, and we believe that requirement engineering is a solution to all those problems. If we sort out our current practices of gathering requirements and gain proper understanding of requirements before we jump to implementation and design, we can build better softwares. And we looked at what are the different requirement engineering process tasks. From those tasks, we started discussing Inception, and we saw what is Inception. We said in Inception we have different set of questions, and by asking those set of questions, we gain some understanding into what the client wants and what are the goal of this particular software we're going to make, and we try to establish effectiveness of the communication that we have with the client. And then we said what is elicitation. So elicitation is about gathering requirements from the clients, and we discussed a couple of techniques very briefly: collaborative requirement gathering and quality function deployment, which can be used to elicit requirements from the client. And so that is it from today's lecture. And inshallah, in the next lecture, we'll continue with the rest of the requirement engineering process tasks. So Allah Hafiz.